Hey everyone, welcome to our next video. Let me go over to our notes. This section is going to be R4, which is polynomials and multiplication of radicals. Now we've already talked about like multiplying radicals and stuff a little bit last time, but for this one, we're going to see some radicals like in the polynomials and talking about what to do with that. So first, I do think it's important to understand like what a polynomial is. So really, you're just going to see some kind of expression that has variables, and then those variables will have exponents. Some things to make note of: there should never be a variable actually in the exponent. It's always going to be like numbers in the exponents, and then we'll see like variables in the normal spot. It's kind of hard to explain just explaining it, but I always think it's easier to see once you have like examples and stuff. So first off, we're going to talk about adding and subtracting. Polynomials. And so what you're really looking for here is you're just combining like terms. And so like terms are going to be things like 3x and 5x, right? So things that have the same variable situation going on. Some other examples would be negative 2xy cubed and 4xy cubed. These would be considered like terms. You can also have square roots in there, but the inside of the square root has to be the same, or not just square roots, it could be cubed roots or something like that, but the root on the outside and then the inside of the root would have to be the same. So kind of we talked about that in example 6 of our last section, like getting, was that the right one? Yeah, of getting like terms and stuff. So let's see, I'll give you an example of that. So I could say like x squared y root 3x and x squared y root 3x. These are like terms, so these could be combined together, adding and subtracting. So let's go ahead and look at some examples. So for example 1, I'm just going to say simplify. Or sometimes for these, you'll see something like perform the operation. So that just means like if there's a plus, you want to go ahead and add them. If there's a minus, you want to subtract them. And we'll do 2 of these. So I've got 3x squared plus 2x minus 1 plus 5x squared minus 6x plus 4. And for part B, I'll write that one on here as well. 3xy plus 5xy squared minus 8xy minus 3xy squared. Almost ran out of room there. There we go. So for part A, let's go ahead and do that one together. We're just going to add the like terms together. So 3x squared and 5x squared, those are like terms. So if we add those together, we get 8x squared. 2x and negative 6x are like terms, so we're going to add those together. So 2 plus negative 6 is going to be minus 4x. and then -1 and +4. So -1 plus 4 is going to be +3. And that's it. That's as simple as we can get. Now for the next one, for part B, I will tell you that my preference would be to distribute this negative. And then after you distribute the negative, you're really just adding after that or combining like terms, however you want to call it. The only reason I think you should be careful here is sometimes what I'll see is people will do, okay, 3xy minus 8xy, and they get that right. They get -5xy. But then when they get here, 5xy squared minus -3xy squared, sometimes seeing that negative negative with each other, people tend to make mistakes there. So just to show a little bit more work, I'm going to go ahead and distribute the negative, and it's really just my preference to do that. That way I don't have any like weird sign issues. So I have 3xy plus 5xy squared minus 8xy plus 3xy squared. So I went ahead and distributed it. That way I'm not having to do like minus minus something. I just already see it a little bit nicer than that. So 3xy minus 8xy, that's going to give me -5xy. 5xy plus 3xy squared, that's going to give me plus 8xy squared. And there we go. Something I'll notice on these for like the test and stuff is sometimes people will accidentally treat this as like multiplication. And I think it's just because of like testing anxiety. You start kind of doing stuff. So sometimes I'll see people do this. They'll like multiply this and then they'll multiply this. And what they're doing there is they're kind of like foiling in a way, but that's not what we're looking for here. When you're adding or subtracting, you're just combining like terms. So be careful about like looking at what the operation actually says. So second here, we're going to look at multiplication. Really, we're going to be talking about a bunch of distributing. So distribution. So I don't usually teach it with like the FOIL method that you may have seen in the past. I like to do this. So I choose a polynomial with the least terms. I break it up, and then I distribute each part to the other polynomial. So I'm just going to abbreviate a little bit there. And so you'll kind of see what I mean whenever we do some examples. So example 2, I'm just going to say simplify. And again, you could see perform operation. So part A, let's see, we'll do 5x squared times 3x squared plus 2x minus 5. Part B, we'll do 8x plus 3 times 2x minus 5. Sorry if I hit the mic just now. So first for part A, we're just going to distribute because we don't have, our first polynomial, that 5x squared, just has one term. So we're going to distribute that to everything in the other polynomial. So this is going to give us, let's see, 15x to the fourth. Remember that you are multiplying like terms in here, so the 5 and the 3, and then the x squared and x squared. 5x squared times 2x, so that's going to give us 10x cubed. Maybe like terms wasn't the best. Same bases is really what I meant. So like the numbers, and make sure that you're adding the exponents. 5x squared times negative 5, negative 25x squared. So this is fully simplified. So for our next one, this is two binomials. So this is when that FOIL method comes out. And so you may know to do 8x times all of that. You do 3 times all of that. That is pretty much what we're going to do here. It's just that I'm going to break it up a little bit and show more work. So I'm going to break up this polynomial, and I'm going to multiply each part of it by the other polynomial. So I'm doing 8x times 2x minus 5, and I'm doing 3 times 2x minus 5. This also shows you that, like, later we'll get to an idea called like factor by grouping and just factoring in general. And what we're doing here when we actually show this work is we're like really showing the steps backwards from factoring. So now that I just have one term times a polynomial, it's a lot easier to have everything organized. So now I have 16x squared minus 40 plus 6x minus 15. And then I'll go ahead and simplify further because I do see that this 40, oh, there should be a 40x right there. I missed an x. This 40 and this 6 can combine because they are like terms. So 16x squared minus 34x minus 15. And that's fully simplified. Sorry about forgetting my x there. Be careful about that kind of thing. I feel like it's super easy to make small mistakes like that. Let's go ahead and do some more. So I have some more for us. Part C. Let's do 4x plus 3 times 5x squared minus 2x plus 7. And then I'm going to start doing some ones with radicals as well. So I'll do 3 plus 2 root 5 times 2 minus 7 root 5. Like I've said in other videos and stuff, I really do think you should pause the video and try to work through stuff like this on your own before I do them. Just want to remind you of that. So for part C, I'm going to break up the 4x plus 3, and I'm going to multiply each part of it times the other polynomial. So I have 4x times 5x squared minus 2x plus 7, and then I have plus 3, and then that times 5x squared minus 2x plus 7. And so I think that just helps us stay a lot like more organized rather than drawing a bunch of lines on here, you know, and doing it that way. Just writing it out looks a little nicer. So 4x times 5x squared, that's going to give me 20x cubed. 4x times negative 2x, so negative 8x squared. 4x times 7 is going to give me 28x. 3 times 5x squared, 15x squared. 3 times negative 2x minus 6x. And 3 times 7, that's going to give me plus 21. And then from here, we just need to combine like terms, put things together. 8x squared, 15x squared, those will go together. 28x, negative 6x, those will go together. So for my final answer here, I get 20x cubed plus 7x squared plus 22x plus 21. Part D, I'm doing the same thing. You could break up whichever one you want since they're roughly the same size. Let me just show you if you break up like the second one or something, just like what that looks like. So this would be, I'm going to break up this one. So that would be 2 times 3 plus 2 root 5 minus 7 root 5 times 3 plus 2 root 5. I just noticed that I've only broken up ones that have like a plus or something, so I kind of wanted to do one that has a minus just to show you. So this is going to give me 2 times 3, so that's going to be 6, plus 2 times 2 root 5, so the 2's will multiply, so that's 4 root 5. And then I have negative 7 root 5 times 3. So the 7 and the 3 will multiply. It's going to give me minus 21 root 5. And then negative 7 root 5 times 2 root 5. So the 7 and the 2 will multiply. So that's going to mean negative 14. And then root 5 times root 5 is just 5. So I'm going to have to multiply this 14 and this 5 together. So let me go ahead and do that. So I'm just continuing to simplify here. So negative 21 plus 4. Sorry, I just yawned. It's going to give me negative 17 root 5. Those are like terms here. The 14 times 5 is 70, so I have minus 70. And now I'm going to be able to put the 6 and the 70 together. So I get negative 17 root 5 minus 64. And it's kind of up to you, like the order in which you write that. So you could have put the 64 in front if you wanted to. I'm not really picky about the order that you write things. In general, it's nice if you're in like descending power order. So like x cubed, x squared, x, and then nothing. It looks nicer if we do that. However, I don't really feel worried about it. You're not going to lose points for me because you didn't put the x squared in the second spot. Like that's not, I'm not worried about that. So I also wanted to do, I have 2 more here for you on this little subtopic. I wanted to do one where the like radicals are not the same. Wanted to do one like that. And then I also wanted to do one that has like a power. So 3x plus root 2, and we're going to say that that's squared. Okay, so for part E, I'm just going to break up the first one again. So 3 times 4 minus 7 root 6 plus 2 root 2 times 4 minus 7 root 6. Now, as you are more comfortable, I understand if you show less work for these. What you feel comfortable with is really more, up to you. So if you are finding yourself, you don't really need to show this step and you just want to do it this way or whatever, that's fine. As long as we get the same answer, I don't really mind the steps you take. It's just that if you are missing stuff or if there's stuff that's wrong, then I want to be able to look deeper into the work. So hopefully I can give you some partial credit. So I'm going to distribute here. So I have 12 minus 21 root 6 plus 8 root 2 and then this is going to be minus 14, and that 2 and that 6 are just going to multiply in the root, so that's going to give me root 12. And now can we reduce anything? Can we put anything together? Let's see. Not really. We don't really have any like terms. However, we can reduce one of the radicals. So we can actually reduce this radical. So let me show you how we can do that. So 12 minus 21 root 6 plus 8 root 2 minus 14. So 12 can split up into 4 and 3. And then 4 is a perfect square, so it can come out of the square root. So that's going to leave me with 14 times 2, and then that 3 got left behind. So now I can do the 14 and the 2 together. So I have 12 minus 21 root 6 plus 8 root 2 minus 28 root 3. And that is fully simplified. The other roots can't simplify at all because they don't have any perfect squares or anything inside of them. For our next one, I want you to be very, very careful. I'll tell you what I see the most of. I'm going to see the most of people distributing that squared. However, you can't do it. You can only do that kind of thing whenever you have multiplication or division in the root, or in the parentheses, sorry, inside the parentheses. If you have multiplication and division, yes, that we do feel like it's kind of like distributing the power. However, in this case, it's not saying to do that. We want to write it out and actually say, okay, this is telling me to do 3x plus root 2 times 3x plus root 2. Just like when something says 2 squared, it's really saying do 2 times 2. Or if something says 3x squared, that's saying to do 3x times 3x. So if something is squared, it's saying to multiply it by itself twice. Well, multiply it by itself so that you have two of the same thing. That's what makes more sense to say. All right, so I'm going to go ahead and break this up. So 3x times 3x plus root 2. And then I have root 2 times 3x plus root 2. So this will give me 9x squared. I see that I'm writing my equal signs now. It's just I kind of forget them. You really should put them every time to say like this is my next step, but I kind of forget. Plus 3x root 2. Can't do anything there. Plus 3x root 2. Again, can't do anything. Plus root 2 times root 2 would be root 4, which is just 2. And we can simplify a bit further because these can combine. So that's going to leave me with 9x squared plus 6x root 2 plus 2. And there we go. That is fully simplified. So do not distribute. That was bad. Like you don't want to distribute the squared or something. That doesn't work that way. For my third little topic here, we're going to do some division. And the division is pretty quick. Just make sure that you divide each term. So we're just going to kind of jump into an example. I'm just going to say simplify or perform operation. And I just have one of these. So this one is 21x to the 7th. Oh, didn't mean to close that. Plus 15x to the 5th minus 12x cubed divided by 3x squared. So whenever you're dividing polynomials, you just want to make sure that you divide each term by the other. So this is going to be 21x to the 7th divided by 3x squared plus 15x to the 5th divided by 3x squared minus 12x cubed divided by 3x squared. So as I'm reducing here, remember when you divide two things with the same base, you're going to go ahead and subtract those exponents. So this is going to be 7x to the 5th plus 5x cubed minus 4x. And that is it. That's fully simplified. So division, there's really not much to say about it. We'll do some more stuff with division and things like that later. I do have one more thing to talk about in this section, and I don't believe it's in the homework for this section. I think it comes up later. I can't fully remember. It might not have come up at all, but it is really important. So I really want to make sure that we talk about it. But it's rationalization. Or we'll just say rationalizing. So what's happening here is when you want to fully simplify things, usually we don't want roots in our denominator. And so we did a problem kind of like this. I think that was in the last video. I'm going to scroll up to it for a second. If you remember part C, example 5, part C, we did 9 over root 3. And I showed you how to rationalize. So we multiplied the top and bottom by the denominator in order to get the denominator to not have a radical. We're going to do a very similar topic, like similar idea here, but if there's maybe like a plus or minus involved, we're going to talk about what to do with that. So we're going to talk about multiplying by the conjugate. And so the conjugate is a really important topic, especially if you're going to end up going into the calculus courses. Not all of you are, but some of you will. So it's really good to have it in mind now because it comes up later a lot. The point of the conjugate is to cancel out the like radical, really. It's like the problem area. So if I have a plus root b, I want to think, okay, what could I multiply this by so that I could get rid of the square root of b? Like, how could I get rid of it? Well, it turns out what you can do is just a minus root b. If you multiply those together, let's see what will happen. We end up with a squared plus a root b minus a root b. So that is going to cancel out. And then we have minus root b times root b is just going to be b. So we're just going to have a squared minus b. So just changing that one sign allowed us to get rid of the radical. Also, if we did, like, let's say it was negative root a plus b. There's two ways you could do it. You could multiply by root a plus b, so change the sign in front of the root a. You could also just change the sign in front of the b and make it negative root a minus b. So you actually have some options when it comes to the conjugate of what you can multiply by. The main importance is just make sure that you're changing one sign. You don't want to change both. You just want to change one sign. And so let's go ahead and do an example of this. So example 4, we're going to simplify, or I'll put a little note here, we're going to rationalize. So the problem we have is 5 over 3 plus root 2. And so we're going to multiply by the conjugate. So the whole point is to say, okay, let's multiply by something for the bottom so that we could cancel out that root 2. So in this case, we're just going to change one sign. I'm going to change the one in front of the root because it looks nicer. So 3 minus root 2. So that's what I want to multiply by. However, we got to be a little careful. If you multiply it at the bottom, you don't want to just change what you have. You have to multiply it at the top as well. The reason for this is when you multiply something on the top and bottom, you're really just multiplying by 1 because anything over itself just equals 1. So if we do it to the top and the bottom, we're really just multiplying by 1. So that's why we're able to do this. Because multiplying by 1 doesn't actually do anything. I hope that makes sense, why you have to do it at the top and the bottom. If not, please let me know. So now I'm going to multiply. So I have 5 times 3 minus root 2 divided by, and then down here I'll have 3 plus root 2 times 3 minus root 2. Usually students don't like when I write sideways, so let me write up and down. So the top, I get 15 minus 5 root 2. At the bottom, I get 9 minus, well, whatever one you want to pick, minus 3 root 2 plus 3 root 2. You can show a little bit more work. I am showing a little less now because we've done this a few times, like multiplying like that. And then root 2 times root 2, that's going to give me minus 2. Simplifying further, so I get 15 minus 5 root 2 divided by, these canceled out. 9 minus 2 is 7. So this is fully simplified. So we just didn't want radicals in that denominator. And really, I just want to show you the conjugate. Like that's really the point of this, is just me showing you the conjugate, because you'll see it later. Again, I don't think that this kind of example comes up in this homework section. I kind of think it does later, but I can't fully remember at this moment. Okay, so that's it for our video today for R4. I will see y'all in the next video. I hope you're having a wonderful day. Bye-bye.